Hello everyone, welcome to MEP Classroom. Today we will be discussing about the typical chill water pump connection details. What you are seeing in the screen now is the typical chill water pump connection detail. We will be going through every single detail which is mentioned in this particular diagram. Let us start from the bottommost part. This is the first item starting in the diagram, which is FFL. FFL means the finished floor level. Once the civil work is completed in the floor, including the painting, this will be the finished floor level. After the finished floor level, we can see the concrete base foundation, which is the base foundation for the pump. Then there is a thick 50 mm thick cork pad, which is meant for vibration damping, and over this starts our chill water pump connections. You can see vibration isolators. Over the vibration isolator, you can see the inertia base. We install our pump in the inertia base. This inertia base will be supported by the vibration isolator on all the four sides. These vibration isolators are meant for dampening the vibration which the pump will be producing when it is in operation to the building floor. If there is no vibration isolator, you can understand that whatever vibration coming from the pump will be transferred directly to the floor of the building. So these vibration isolators are meant for dampening those vibrations. Let us go to the pump connections now. We have the electric motor, which is the driver for the pump, and you can see this is the discharge line and this is the suction line. The easiest way to understand a discharge line and a suction line is a strainer will be always present in the suction line, because the purpose of the strainer is to remove the impurities which is going to the pump, and a double regulating valve, the DRV, which is meant for measuring the chill water flow of the pump. It will be installed always in the discharge line. Let it be pump, let it be AHU, let it be FCU. For all the connections, the double regulating, for the FCU there will not be a double regulating valve. Nowadays it is PICV. Let us discuss all those things in the later videos, but just for reference I am telling, all the measuring devices for the equipment will be installed in the discharge line. So we can easily understand, as the strainer is here, this will be the suction line and this will be the discharge line. Let us look into the suction side. In the suction side, you can see something like this here. This is called a flexible pipe connector. The purpose of a flexible pipe connector is to remove the vibration or dampen the vibration coming from the pump towards the pipeline network. This flexible pipe connector is in both suction and discharge side. You can see the flexible connection in the discharge side here. The flexible connection from the suction line is here. So these two isolates the pump from the pipeline connections. These both are meant for dampening the vibration from the pump towards the pipeline connections. So let us look to the section side. After the flexible pipe connection, we can see a pipe support here, which is supporting the pipeline. Then there is a drain cock meant for draining the chill water if we need to drain the chill water. Then there is a strainer. As we discussed earlier, the purpose of a strainer is to remove all the impurities if any is present in the chill water before it is going to the impeller, because if any impurities goes directly towards the pump impeller, it will damage the pump impeller. So there is a strainer here. Then there is a pressure gauge here. Then there is a gate valve. A gate valve is meant for isolation. Like if you close the gate valve, there will not be any flow. It will block the flow completely. It will isolate the flow. Then this suction is coming from the suction header. So this is the suction header here. So it will be coming from the suction header. Let us look towards the discharge line now. There is a pipe reducer here, which is meant for the connection. Then there is a flexible pipe connector. As we discussed earlier, it is meant for isolating the vibrations from the pump. Then there is a check valve. This is one important valve in the discharge line. The purpose of a check valve or a non-return valve is to ensure the flow is only in one direction. This will be a like when the pump is operating, the chill water will be flowing in this direction, like from the pump towards the discharge line. So what will happen if the pump gets switched off? This is a huge pipeline. What will happen? All the flow in the pipe will come in the reverse direction. So if it come in the reverse direction directly to the pump, it will damage the impeller. So the purpose of an NRV or a check valve is to block its flow. This NRV is a one-way valve, means it will allow flow only in one direction, meaning if the pump is operating, flow will go in this direction, but it will not come back in the reverse direction. So that is the purpose of the check valve. After that, there is a pressure gauge which is meant for measuring the pressure. Then there is a double regulating valve. As I mentioned earlier, this double regulating valve is meant for measuring the chill water flow coming from the pump. Every chill water pump will be having a double regulating valve, and we will be measuring during the commissioning stage or the testing and balancing stage. If you just want to measure what flow is coming from your pump, you will use a podimeter or a mercury manometer. We will connect it to the double regulating valve. We will discuss more about double regulating valve in the coming videos. Here just understand that this is meant for measuring the chill water pump flow, and it will be connected to the chill water discharge header. You can see this will be a discharge header. If for example, if you are having 3 or 4 pumps, all the pumps will be connected to this single header, and from the header it will be connected to the other branches. This is just a representation in 3D if you just want more clarity on this. So this will be how the structure will be like. Ignore all the calculations on the left hand side. It is just about the inertia based calculation. Just look into the diagram. See, this is the inertia base, and this is the vibration isolator, what we were discussing. All the 4 sides you can see the vibration isolator, which is isolating the vibration from the rotary pump towards the ground of the building, towards the floor of the building, and these are the flexible pipe connections which are isolating the vibrations from the pump towards the piping network. This is the pipe support we already talked about. So this is how it will look in 3D. Hope whatever discussed so far was helpful to everyone. Thank you so much for watching. Whatever doubt you have on the topic so far I have discussed, you can feel free to ask in the comment box. I will be replying all of you in the comment box. Also, please suggest whatever topic you want to discuss in the coming videos.